Welcome to my Spring 4 web applications talk. My name is Rossen, Stoyanchev. I work on the Spring Framework team. I focus on anything web related, Spring MVC, WebSocket, and now we have the reactive effort for Spring 5. So Spring Framework 4.3, as you probably heard from the keynote this morning, is the last feature release for 4.x. And it will have extended support on JDK 6 through 8. Of course, Spring 5 is Java 8+. And it will also have kind of extended range of support for runtimes, Tomcat 6 to Tomcat 8.5, and then WebSphere 7 to 9. So basically, if you need to be on JDK 6 or 7, then basically the answer there is 4.x. We plan to continue to maintain it and to support it, but there will be no more new features. We focus with new features on Spring Framework 5. So in this talk, we will cover what those new features are that are rounding off the 4.x release. And actually, there's plenty of improvements around the programming model. There's quite a few new annotations, at MVC annotations. So that's where we're going to start because those are the most visible in the programming model. So the first one was support for shortcut annotations. So we actually added the ability to create your own custom annotations for request mapping back in 4.2. And at the time, we began to already think, are there any custom annotations that we can provide out of the box? And we had a lot of back and forth, a lot of debate about what exactly we should provide. Obviously, one thing that we really wanted to avoid is having kind of different flavors of annotations out there that would make things quite confusing. It's one thing to make your own custom shortcut annotations, and it's a very different thing for the framework to provide them and to have them supported like that. And interestingly enough, a lot of heated debates came out within the Spring team, a lot of different opinions with something as simple as what to call these annotations. This is what we settled on in the end. So one of the major alternatives to this was to simply have @get, @post, @put, and @delete, which are much shorter. And it's reasonable to say, why not just do that? To some degree, it's a matter of there's some subjectivity involved in making these choices, but certainly what we wanted to ensure is that there's a kind of consistency between the request mapping annotation and those other annotations to kind of reinforce that. And also, as you know from JAX-RS, we already have those annotations in use with JAX-RS, and it would be a little confusing to have both of these out there side by side. So this is what we settled on in the end. And the main reason, we did have additional opinions that we should not have these custom annotations at all, because they do make things more confusing to have that extra choice. But really, the reason why we decided to include them is because at the end of the day, the request mapping annotation is arguably too general for the most common cases. So for example, in most situations, I think it would be a good idea to include the HTTP method information and the URL pattern in a request mapping. Whereas today, in reality, what happens is that many times you might just declare request mapping with a URL pattern and then leave it at that, which means that it matches to any HTTP method. And while that works, it's not ideal because you really should kind of specify it more explicitly. In most cases, it's either a GET or a POST. It's not very common that you're processing multiple different kinds of HTTP methods with a single controller method. So by doing this, we actually have a huge saving already. So if you take a look at a typical method, by the time you have to specify the request method as well, it really becomes quite long, and you can replace that now with a GET mapping with just the URL pattern. So that makes the most common case much easier to express. So that's kind of in the spirit of make the right thing easy to do and then leave it at that. Now, the other thing where we debated and went back and forth and kind of made a refinement of the approach, originally we also decided to take a bit of an opinion with which attributes were exposed on that annotation. Obviously, these are different annotations. A composed annotation allows you to create a subset or a superset of attributes and then use aliases to map them to the request mapping annotation. So we decided that some of the attributes are maybe not so common. Maybe we don't need to expose those. But then we went back on that. And at the moment, the way that this works is that the get mapping exposes exactly the same attributes as a request mapping, with the philosophy behind it being that the reason why you use get mapping in the first place is because you want a shortcut annotation to express the HTTP method, but aside from that, there should be no other reason to switch back and forth. Certain scenarios where you use request mapping, certain where you use get mapping. If your handler method only deals with one HTTP method, there should be no reason to ever switch back to request mapping. Now, keep in mind that request mapping is still something that you might need at the controller level, at the class level. Clearly, we don't want to lock down the HTTP method in majority of cases at the class level. We simply want to express a path or pattern. So that's where we have a request mapping here at the class level, and then at the controller level, we use get mapping that is basically, again, a shortcut for the HTTP method. We have similar shortcut annotations for request scope, session scope, and application scope. The idea is the same. We have a scope annotation currently where you have to actually indicate what the scope name is. That looks like this, and you can now just replace that with something that's obviously easier and nicer to type. Now, another feature request that started out a little differently and ended up with this, we now have the request attribute and the session attribute annotations. So the idea behind this is that it's very simple. It's basically access to request attributes and to session attributes. So this is an alternative to having the request injected into the controller and then out of that, getting the request attributes or session attributes as needed. So we can do that with one and the other. And it's really as simple as that. It's just access to those attributes. But where the request started out, and not to be confused, is with the session attributes annotation with an S at the end, which is a controller class level annotation that some of you may have used. That is really a way of indicating that some of the model attributes should be promoted to the session because we have maybe a form controller and we want to save the model attribute in the session between requests so that we don't have to re-retrieve it, let's say from a database. And I think the original request was actually to get access to a session attribute, and could we maybe make the model attribute, could we change the model attribute annotation so that it allows it to be optional. And we looked at it, and basically at the end of the day, this is about read access to session attributes that are created externally to the controller, kind of global session attributes. So we ended up providing request and session attribute annotations. So this is the use case that I mentioned with session attributes at the class level, not to be confused with what we just added. You can see here that we are accessing a model attribute called foo, and then the purpose of the session attributes annotation at the class level is to basically say that that foo should be kept in the session between the get and the post. Another new annotation, another new addition, which is straightforward. So you may be familiar with controller advice and also with REST controller. The REST controller is a kind of a stereotype annotation in addition to controller that basically assumes REST semantics, meaning that by default, all the controller methods are response body instead of HTML rendering view resolution. Where the controller advice is a way of externalizing some of the auxiliary methods within the controller, like the model attribute, the init binder, and probably the most common one is the exception handler methods, that you can make those shared and global across controllers. If you haven't used the controller advice, that's really its purpose. So you can put something like an exception handler method in a shared class that's used across controllers. So now we have a REST controller advice, and basically that's a combination of these two ideas, that any exception handler method is going to have response body semantics by default. We also have a flag on the model attribute now that says binding equals false. You may wonder what the use case behind that is. This is kind of the specific request that we had, which made sense why we may want to sometimes disable binding. It's automated, right? If you have a model attribute declared on the controller method, we're going to try and bind the incoming request to that command object, to that model attribute. But in this case, what's actually happening is that we're preloading the object into the model. So it's already there. And then when we're performing the update, we're getting access to that object. But what we actually want to bind the request to is the foo form. So that's a separate object. We're not directly binding to our domain object. So this is actually even kind of a security concern there, because we don't want to bind into foo and potentially overlay its attributes. So that's really what this is meant for. It's a simple flag that says binding equals false. HTTP options and HTTP head. So we have automatic handling for this within the framework. This is something that is one of those things that we probably should have added a long time ago, but for one reason or another we never did. But now we have built-in support for that. The story with HTTP options is that up until 4.3, the dispatcher servlet basically has a flag that says, do we know how to deal with HTTP options or not? And by default, that flag is false, which means that we assume that controllers are not actually prepared to handle HTTP options. And if you're not familiar, HTTP options is basically returning a response that says which HTTP methods are we expected to be able to handle at this particular URL. So you would have to, so basically what would happen today is that you would get an automatic response which is based on what the base HTTP servlet provides, which basically lists all the HTTP methods. In other words, we don't really know for sure, and we're just returning all the HTTP methods, and that's the default functionality. Now, you may have developed your own solutions, and probably many of you do, but now we have automated handling because Spring MVC is actually in a very good position to indicate what HTTP methods can be handled for a particular URL, because we know all the mappings of the controllers, and we can extract that information. And for HTTP head, well, the idea there, it's actually was very close to working. With HTTP head, I mean, the way that's supposed to work is if you have an HTTP get, then the head should be identical minus the body. But that does mean that all the headers should be identical. If you have a content length, content type, all of that needs to be in the response, everything minus the body. So literally, it's about allowing the controller to do what it does and then just ignore the response body. And in fact, the HTTP servlet, the base HTTP servlet class that dispatcher servlet extends from, already has head handling. But the issue really comes down to the mappings. If you have explicit mapping to HTTP get, and we now recommend it in 4.3 with the get mapping, basically that's not going to match to HTTP head. But if you just have request mapping without any HTTP methods, it just works. So we just had to kind of fix this up a little bit. Here's an example with HTTP options. You can see here that This is going at a particular URL. So what we do in Spring MVC now is that we handle HTTP options. We have built-in support for that. And when the request gets to the handler mapping that deals with annotated controllers, we let it work through the mappings, and if there is no explicit mapping, if there is no handler explicitly mapped to HTTP options, then we take over from there and we say, okay, let's take a look now which methods actually match by URL and everything else. And now we know which HTTP methods we can actually can be handled at this URL, and we prepare the response and return it. So there's automated handling for this now. And notice also that in the allow header in the response, we're including not only the get, but also the head, because we also explicitly support that as well now. And this is an example with HTTP heads, and this is a get mapping again. What happens here is that now anything which is mapped to HTTP get is also implicitly mapped to HTTP head as well. We treat them that way in the request mappings, and we essentially allow the mapping to occur, but the body gets ignored. Everything that happens to the response includes only the status and the headers. So that means if you have built-in support for this, you no longer should need it. It's built into the framework. Another feature that we added in 4.3 is the forwarded header filter. How many of you use the MVC URI components builder or any of the link kind of builders? Okay. So we have actually a very convenient class called MVC URI components builder. And you can point it to a controller and a controller method, and that will allow you to build the link to that particular controller method. So it's very useful if you don't want to embed a specific path information when you need to refer to another controller method or to send a request. And that will automatically deal with forwarded headers. So these are things where HTTP proxies may switch the host or the port and then forward the request. By the time it gets to our application, it already has a different host and a different port, for example. But there are headers to indicate that, and when we build links that are provided back to the clients, they really should have the external, the original host and port information. So we look at those headers for the MVC URI components builder. We automatically do that, but basically the request was that there should be a mechanism that does this more globally across for the entire server-side web processing. So we now have a forwarded header filter, which is just a different way of packaging what we already had as a filter, which wraps the request so that when you start using that request, it's consistently sees the information that was passed on to us in the forwarded headers. And that includes things like looking at the context path, things like looking at the servlet path, the path info, all of that is included in the wrapped request. In the REST template, we now support default URI variable values. So you may have a situation like this. You can see here we create an instance of the REST template, and then we give it a set of default variables to use when we're preparing the URI template. So in this case, maybe the host and the port is the same in most cases, and you don't really want to repeat that with every call to the REST template. So instead, we're going to provide those as default variables. And then when we actually make the requests, all we need to do is provide whatever is not there. And this is actually an interesting, the underlying mechanism beneath that is interesting because it provides pluggability into the URI templating mechanism. So if you, for example, weren't entirely happy with the encoding, the way that it's done, with the URI template, or if you wanted to plug in a completely different templating mechanism, maybe something that's compliant with RFC, with the RFC for URI templates, which has very extensive syntax that's different from the one that we use, then you could plug in even an external templating library and use that with the REST template. We made some improvements to the client-side mock REST tests. How many of you use that? That's the part where you want to test things that depend on the REST template, but you don't want to hit an actual server, okay? So what we have there, and you can see an example of it if you're seeing it for the first time, that gives you an idea. So I have some code that's using the REST template, but I don't want to actually hit a server. So I'm going to create a mock REST service server, and I'm going to bind it to a REST template. So now the REST template, instead of making actual calls, is getting essentially canned responses. And the way we do that is we set up expectations, such as the ones you see here, where when we have a request to /foo, we're going to respond with HTTP status of 200. So we can set up expectations like that. Now, what's new in 4.3 is that we can now indicate things like the order of the expectations. They don't have to be in exact order. So if that suits your pattern of testing, then you can tell it to ignore the order in which the expectations are set up. And also, there's a whole variety of options to indicate how many times a particular expectation should be present. So for example, here we're indicating that /foo should appear 2 times, or /bar should be 3 times. And then at the end, you can say server.verify, and you can be more precise like that in the expectations. Okay, and then we have, of course, the ongoing work for Spring Framework 5. I had a session on that earlier, so I'm not covering any of that here. The Spring Web Reactive story, well, we're basically providing an additional Web Reactive module next to Spring MVC in support of the same programming model on top. So that's definitely something to check out already. It's in the first milestone. We have server-side REST support and client support, and all of that is practically in shape where you can try it for specific use cases. What we plan to do from here for subsequent milestones is expand the support to improve HTML browser style applications. We have HTML rendering support, so we have view resolution in the reactive side, but we don't have any support for data binding and for submitting form posts. That's something we're still going to add in subsequent milestones. But the rest, the idea was to try and take a vertical slice of something useful, so you don't run into too many surprises as you try this out with milestone 1. So if you're focused on REST scenarios, pretty much everything you need should be there, the basic stuff. Another interesting addition to Spring Framework 5 that's in the works, it's not in milestone 1 yet, but it should be in one of the subsequent milestones. Since Spring Framework 5 is actually Java 8+, it really makes sense to try and experiment with a more functional style programming model for web applications. We have Lambda expressions. So some of the early prototypes that are already have been created include a kind of a functional approach to taking the request and providing the response. And instead of relying on annotations and flexible method signatures, it's more in your hands. It's kind of more functional style. Where you declare what needs to be done. So if you're dealing with data binding, or when you're dealing with message conversion, you would say request.convert from, and then you provide the body of the request, or actually that's a method on the request itself. So you're more explicitly driving things, but still it gives you the methods that you need to actually still make that easy. So it's basically a different way of achieving the same thing. And it's looking pretty appealing. I think this will definitely be popular, and it'll be nice to have that side by side with what we have currently. And of course, also HTTP2 is a specific goal for Spring Framework 5. We don't have anything specific at the moment, but you can expect some things in the client side, and also whatever comes out of the Servlet 4 API. I guess a lot of the changes are actually at the server level, because a lot of what changes with HTTP 2 is at the protocol level, so it's not so visible on the server side, but there will be some additions there as well. So that's pretty much all I had to say. Are there any questions? I think we have a couple of minutes. Okay, one question. The question is, can you combine the shortcut annotations, get mapping, post mapping on a single method? No. So the answer is that, I mean, the goal is to actually be explicit about the HTTP mapping, so it's kind of the opposite. If you really want multiple HTTP methods, then what you want is the request mapping annotation. Okay? It wouldn't be synchronized with this necessarily. There are separate projects. I'm actually, I haven't looked there recently, so I'm not sure if, I'm assuming that they don't provide that, since you're asking the question. Yeah, so I would check. If they don't provide it, you can make a request. There's an example. We don't share any code there, but there might be some ideas of, at the API level at least. So if I understand the question, it's you're confirming whether for single page apps as well, HTTP 2 really doesn't mean a lot of change on the server side? Yeah, I mean, I think regardless of the kind of application that's on the client side, again, a lot of the changes are at the protocol level, so servers have to do a lot in order to support HTTP 2, but from a programming model perspective, and if you look at the proposed changes for Servlet API, it's almost nothing. It's mostly about the pushing of resources proactively back to the client. At the moment, they're not even exposing any of the flow control, which we would be very interested in on the reactive side, but there's nothing along those lines at the moment. Okay, one last question, because we actually do have another session. Yeah. Yep, there's a TLS issue, and that's on the EG. You can see the discussions that are going on there. Unfortunately, there's no ideal answer at the moment. So I'm going to have to actually stop, and we can continue, but there is another speaker coming up, so I want to give up the stage, and we can continue. Thank you.